So everyone, as we talked about today in class, we talked about rolling 2 die and coming up with a table that represents all 36 possible outcomes. We also talked about why there are 36 outcomes, specifically because there are 6 choices for one of the die, and then there are 6 choices for the other die, so then there are 6 times 6, or 36 possible outcomes. So just to connect the probability to the counting, notice what we did here is we used the fundamental counting principle to figure out how many outcomes. So then if I were to ask you, what's the probability of rolling an even number on the die, how about the sum of the die is even, then what I would have to go through, and I'd have to say, well, they add to 2, they add 3, add to 4, 5 of them will add to 6, then 5 more will add to, so 1, 3, 5, 5. 5 more will add to 8, 3 more will add to 10, and 1 of them will add to 12. And this, of course, adds up to 1, 3, and 5 is 9, 5, 3, and 1 is 9. So the number in the event of an even sum, or the sum is even, divided by the number in the sample space, is going to equal 18, and we've just written down all 18 of them here, divided by 36, or there'll be half a chance. Now notice, this counting right here gave us the denominator, the total of 36 outcomes, by the fundamental counting principle. The numerator we got based on observation from the table, or essentially my little blue lines talking about it here. If you want to confirm this, just look at problem numbers 35 through 40 in your textbook, and you'll see the whole table there. That's actually a beneficial table to know and have memorized. It'll help you out on lots of problems. And so you have all seen the typical spinner. For instance, the game Chutes of Ladders uses a spinner. Some games use dice, but there are lots of games that use spinners to move. And you flick it with your finger, and then this dial will spin all the way around, and the number it lands on is essentially how many spaces you move. And so typically what happens is we make these triangles all the same size. I didn't do that because I'm drawing it freehand. But if we assume they were all the same size, they'd all have the same measurement in degrees. Since there are 360 degrees, we'd divide that by 5. We would know each angle is 72 degrees. And that's the fundamental principle of spinners, is that every triangle's the same. Every sector is the same. If that's the case, then there's the same probability of landing in each sector. And so in this case, it would be to land in the sector containing 2, the probability of a sector 2, you could think of it as 72 out of 360 degrees, or you could think of it as 1 sector out of 5 sectors. So it just depends if you want to make your sample space the number of degrees in the sector, or if you want to make your sample space the actual number of sectors. But in either case, 72 over 360 reduces to 1 over 5. And so this becomes just a handy way to help us think about spinners.